In this video, we want to discuss moral hazard as it applies to insurance. We've discussed moral hazard earlier in the course, where we talked about it, for example, when somebody was buying a house, whether the realtor experienced moral hazard in helping the person buy or sell a house, for that matter. Before I get to the model, which is over here, let me show that on this particular spreadsheet there is a rather extensive discussion, and I'm not going to go through this discussion at all, but I do encourage you to read it immediately after watching the video. It's not that long, and it explains real-world insurance and some related issues. So here, when we do the model, we are going to do it algebraically only, because graphing is a little bit hard. Let me explain why. In this example, the consumer can affect the probability of loss. If the consumer takes precaution, they can lower the probability of loss to Q, where Q is less than P, the probability of loss, when they don't take precaution. Because the indifference curves themselves depend on the probability of loss, it's going to be hard to keep track of preference when you have these two different probabilities floating around. So we're only going to do this algebraically, and we are not going to look at this analytically, graphically. When they take self-protection, there is an effort cost, E, and we are going to assume that the consumer is effective in taking self-protection. So if you look at the expected loss with self-protection, which is QL plus the effort cost, that is supposed to be less than the expected loss without self-protection. So self-protection is productive here, and from a society's point of view, it would be good if the consumer took that. So let's scroll down a little bit here. I'm not going to prove this algebraically, but if the original probability is not that large, if P is small enough, then the expected utility of the lottery, where W again is the initial wealth, L is the loss, so this is the probability times the utility when you are taking precaution and you face a loss. This is the probability of the utility when you don't face a loss. That expected utility is actually bigger than the expected utility if you don't take precaution. So this consumer has incentive to take precaution in the absence of insurance. And now let's scroll down a bit, and what we will see here is that when they have insurance, they pay the premium S, so you subtract S in both states, but they have the coverage I, so I reduces the impact of the loss. And what's becomes quite clear is that when I equals L, that is when there is full coverage, in fact, then the payoff is independent of the state, and it doesn't matter whether it's Q or P, they get the same payoff. So why incur the effort cost E if you have full coverage? So with full coverage, there is no incentive to take precaution. With no coverage, there is incentive to take precaution, and then you can reason that there's some place in between, which is the maximum amount of coverage that will induce precaution, and the insurance company will not offer more than that maximum amount. The difference between that maximum amount and full coverage is the deductible. So this is an explanation based on moral hazard about why insurance policies have deductibles.